So whenever you're ready, we can go. Are you ready?
Yeah.
What is up? We are going live. Datadog Kubernetes community live stream number 104. We are with a member, not of the Fantastic Four, but of the Fantastic Five, or I don't know what superhero crew he's in. He's a Deadpool fan. Deadpool may be making an appearance, as well as other superheroes in this particular live stream. But before we get started, we're getting close to the holiday season. Holiday season is a good time to read a good book and avoid your family, all right? Our families are wonderful, but sometimes we can get saturated. So if you need to do that, I highly recommend checking out the Datadog Kubernetes Community 2021 Research Report. You'll find lots of good stuff there as a way to educate your families on what Datadog Kubernetes is, the impact it's having, and why the 500 organizations we interviewed say that they believe there's a lot of future in it. So that's one piece of literature I'm going to share with you today. Another piece of literature that we're going to be sharing is a very fascinating blog post that was written not too long ago by today's speaker. His name is Nick. I'm going to be very brave and try to say your last name correctly with my horrendous American
I'm curious.
accent.
Go for it.
Vermande?
Yeah, with Vermande, yeah. But in English, so I just said, you can say Vermande.
Vermande.
Vermande. You know, it's easier for English-speaking people to pronounce it this way.
Yeah, Vermande. Well, anyway, Nick, it's very nice to have you with us. You're rocking out developer advocacy at Ondat. But apart from that, you've got purple hair, kind of got a mohawk, you've got tattoos. We did a Twitter Spaces last week, which is a lot of fun. For the folks who didn't attend that, can you just give us a brief summary of who you are and what makes you so unique?
Oh, I don't know if I'm unique, but...
Oh, you are.
Yeah, so I'm Nick. I've been working with Ondat for, the past two months, something. And then before that, I worked for 6 years at Cisco. So I'm also focusing a lot on the CNI. So not really the data part, but mostly the networking part. So working in engineering organization as part of the technical marketing team. Mm-hmm. So doing a lot of stuff around education, product management, also talking a lot of conferences, things like that. And Kubernetes probably for the last 5 years. And before that, I was doing a lot of virtualization. I'm a double VMware VCDX as well for my past life. Okay. So I've been doing system Linux for the past 15 years, something like that. So
a lot of experience. Yeah, a lot of experience. And it's nice that you've seen all that, but here you are now very much focused on this aspect of running data on Kubernetes. And just for folks that you're definitely going to want to read this, I'm just going to link it now. Nick had a blog post that came out not that long ago, about 10 days ago, about how stateful apps in Kubernetes are a big deal. So that's required.
And I've got another one. Yesterday, I released a new one, which is called, I can't remember the name, but it's basically the same kind of thing I'm going to be talking about today. It's about shifting left and doing some sort of on-demand with shift left with data and bringing this whole, cloud native workloads into the real on-demand for developers. Right.
Okay, well, let's start shifting left. We can get the blog post later and link that in. But yeah, let's shift left together. Let's do it.
Okay, so let me share my screen right now.
Good. As usual, folks, while Nick's presenting, if you have any questions, comments, doubts, concerns, etc., please leave them in the YouTube chat, and we will happy to get to them accordingly. That being said, Nick, it's all yours.
Okay, thank you. So again, I'm very glad and super excited to be there, especially with you, Bart, because I know we share a lot of interest. So hopefully it's going to be fun. So the talk today is going to be about how to enable self-service infrastructure by shifting left your data with Kubernetes. A long title with a lot of different words, right? We're going to be talking about what can be considered as self-service in the cloud and how cloud native relate to cloud. It's more like a blue pill, red pill kind of thing. We're going to try to analyze that. Then we're going to see how to do it with Kubernetes, how to provide and to help developers. So this is probably what I'll be trying to focus on today, is on-demand services for developers, but it can also be extended to anyone who wants to consume some sort of application and deploy application in Kubernetes. So maybe application owner, can be platform admins, can be other type of personas. But today I want to focus on the developer because I want to show you some code and the Marvel app as well. How cool is that? Right?
Oh yeah, there will be a Marvel app. Yes.
And then how to, so I will also install, I have a demo for you. So probably I'm going to try to spend probably half the time on the demo, because it's going to be a full CI/CD pipeline on how to bring, persistent, stateful application data into the picture from start to finish in terms of the development lifecycle, like from the laptop to public cloud in your production Kubernetes cluster. So there's a lot of different tools to cover. So hopefully this is going to be fun. And I'm going to ask probably people some question about, I've done things in a certain way. I've used specific tools. I've tried to stay within the Kubernetes, environment, so Kubernetes tools. But if at any point in time, people, can say, okay, I'm doing it this way, or we do it this way in my company because of X, Y, Z. I'm also quite curious to hear about that. Right. Okay, so let's get started. I think I don't really need to introduce myself anymore. So again, I'm working for Ondat. I'm a principal developer advocate. You can contact me or follow me on Twitter there. There's my handle. Let's get started. So the first question is how Cloudnative is related to cloud. Is it the same thing or maybe not? Right. So in the context of this talk, I'm going to be focusing on Cloudnative as the CNCF, let's say, landscape or definition of it, like mostly like running Kubernetes workloads, as opposed to the cloud definition. If you look at the NIST definition of cloud, which was probably the most comprehensive way of defining cloud, they say it's essentially, it's a model to enable access to a shared configurable pool of computing resources that can be rapidly provisioned or released with minimum management effort or manual action. Right? That's essentially the definition of cloud, right? But the way most people consume cloud today is by using public cloud. And that fits well also with Kubernetes because you can find many different distributions of Kubernetes in the public cloud. You have EKS, AKS, right? All these kind of services. But so those things, the workloads or all the services you can ask on demand in the cloud service providers, what they are going to tell you is that, it's the economy of scale. We can go super fast to deploy our workloads. You can consume any service is going to be provisioned in 2 minutes. That's perfect. But when we start talking about deploying, complex application or, resources that have a lot of dependencies between each other, usually what cloud providers don't tell you is that you have to put a lot of glue, right, to make those services work. And also those cloud service provider, they all have their own way of doing things, especially if you want to put some glue together. It will be pretty much specific to one particular cloud. There's no real way of standardizing thing, right? So as you need more glue between the different elements, what you tend to lose is the on-demand aspect of it, right? The on-demand or self-service aspect to it, because at some point you will have blockers, right? You will have blockers because, I didn't create my script to do it, so it has to be manual. It has to go through, another. Maybe at some point you're going to come up with a script or some automation, but it takes time to get there, right? So essentially, what I'm trying to say is, look at this picture. This is kind of reflecting this. You have, the magic world of the Care Bears on the top, but the hidden part of the iceberg, which is really big, is probably the amount of time that you're going to spend trying to put your own IP to make the on-demand part happen in the cloud, right? And this may happen for various reasons, because once you are in a single, probably you're going to start with one cloud, or today your company is sitting with a single public cloud, but chances are that's really fast, you're going to consume resources and deploy services in more than one cloud. So everything I've mentioned around, putting the glue, using cloud-specific tools to build your on-demand services, you will just need to rinse and repeat again with other clouds. So imagine that you have to, again, deploy new skill sets, and you have, you have to face your learning curve with the new cloud. So again, it's going to delay whatever you want to release on that cloud. If that's an application, if that's a particular, CRM software, whatever, something that you have the IP for, you're just going to deduplicate all the effort, right? But there are very, very good reasons why companies are doing it. Can be things like ELA, maybe, I don't know, if you're a Microsoft customer and you use a lot of Office 365, then Microsoft can propose you like some, Azure credits. So why not, right? You're going to be starting to use this cloud. If you're using big, Oracle databases, maybe Oracle Cloud would be the right fit because they would give you a discount. Also, with a lot of mergers and acquisition, maybe the company you're going to acquire may be sitting in another cloud. So you have to learn all those things. And also high availability, although this one is not necessarily, I would say, a good reason to use multiple cloud, because as long as your workloads are located in different AZ or different region, you tend to be safer. Right? But still, if you don't trust a particular cloud, then you may want to implement your services into more than one cloud for a high availability. So a couple of challenges. Again, they all have different APIs. They will all use different SDK, different libraries. And in terms of DevOps and building the automation around what you want to deploy or develop, then you will also find different proprietary services and tools, the equivalent of Git, the equivalent of Ansible, or all those type of things. Like declarative model in every cloud will be different syntax, and different trainings in the end. So you have to, your company has to invest into people, and you personally have to invest into training and develop your skills, which is not a bad thing, but depending the amount of work you have to put and the amount of time you have available, of course. And so you end up with a plate of spaghetti. So hopefully I don't make anyone hungry yet, but this is what I was trying to show here. You end up with a sort of a plate of spaghetti of different libraries, APIs, SDK, and all of that. Which brings me to the point I'm trying to make, right? We need some sort of standardization. And this is where I can make the relation with cloud native, right? And when I say cloud native, it's Kubernetes. So Kubernetes is bringing this kind of standardization or cloud framework you can use typically in any cloud, right? You talk to Kubernetes in GCP, you can talk Kubernetes in AWS, you can deploy your Kubernetes cluster anywhere, essentially. And it's not something new. If you look at what HashiCorp did in the past, they brought Terraform as the framework or as the standard way of deploying and managing the life cycle of resources in the various environments. Can be in public cloud, all the cloud providers. You will have a Terraform provider for that, or even on-prem like vSphere environment. All that they can support this as well. And you also have more, let's say, code-friendly solutions like Pulumi, because I don't know if anyone has ever tried to do like a more advanced logic into Terraform. Just like creating a loop can be quite challenging in Terraform. You have to do a lot of transformation, etc. So it can be a pain in the neck, to be honest. But still, the purpose is to standardize the creation and the definition of resources. But it doesn't solve everything. It's not like Terraform is not the solution of all the pains you have when you migrate to cloud. So one of them is that it's very difficult for Terraform to provide day-to operations and to kind of reconcile the modification you're doing in production back into your configuration. So typically in Terraform, you have your declarative model, which is HCL or JSON, and then you deploy your different resources into your environment. So they can still do dry. So dry stands for don't repeat yourself. It's a kind of a paradigm you want to adopt when using Terraform. So you always have the different environment like dev, test, staging, production, and you will create different manifest or different scripts for Terraform to use. So you can still deploy different configuration and different parameters depending on what kind of environment you want to deploy into. But the challenge is if at some point you don't use Terraform to modify your environment because you need to do it in an imperative way, there's no way, or it's tricky, very tricky, to apply the changes in the opposite direction. So from your running environment into your Terraform configuration, right? So yes, the expectation is to perform data operation on demand too. That would be our ultimate goal with, at least with Kubernetes. This is what we are going to try to achieve. And there's a way to do it in Kubernetes, and I'm going to talk about this a bit later, which is Git Ups, right? Git Ups allows you to take configuration, inject it and ingest it into and apply it into Kubernetes. But then if you do any modification into Kubernetes, you can also revert the direction and say, okay, I've done this configuration, now update my repository with that particular configuration, right? So it's going one step further, also in the sense that Terraform is not meant to be a runtime for application. So Kubernetes is. So what I'm trying to say is, don't solely rely on Terraform to do everything, but probably Kubernetes, I may be a bit I would say biased or opinionated on that, but I believe Kubernetes, to begin with, is the ideal platform to automate anything. Not only for stuff you're going to be running in Kubernetes, but also other environments. So for example, if you want to automate AWS workloads or AWS services, or anything that's run in another cloud that is not related to Kubernetes at all. And actually, there are companies who are already doing this today. For example, if you take a look at the Crossplane project, and I think the company is Abound behind it, they propose to do that, essentially using using Kubernetes, as an automation engine for that, not only for running application, but also to run the automation to deploy all your services on demand for things that are external to the cluster, essentially. Hope that makes sense. So I don't know if there are any question on that before I move to more of the using Kubernetes as a common framework.
When you mentioned the aspect of automation, I would like to know, in your particular case, what are things that you would like to see automated on Kubernetes that haven't necessarily been automated yet?
Yeah, that's a good question. So inside Kubernetes, I think we are pretty much covered in terms of probably like the application. We have, one can argue, we have build packs today to build application from the ground up, right? So I would say, but this part is still in the early days. So automating like building application and the whole deployment and management of the application, I think it's an area that needs a bit more work. Although, and back to your question, I'm going to show you how to create a CI/CD pipeline natively in Kubernetes using container. So it's based on Tekton. And I think Tekton is fantastic because it's kind of, with Tekton, you can automate anything using Kubernetes. Yeah. Right? So you can automate anything in Kubernetes, but also other things. But for me, it's still a bit, not immature, but kind of super complicated because it's super flexible, but you have to configure all the moving parts. Yeah. So all the parameters, the values, all the different actions you need to do. It's very, very granular, but also very, very flexible. So which comes at a price, right? So my point also, another point is really to, what I'd like to see is is exactly what I was saying before, is automating things that are not inside Kubernetes, and maybe even make people feel that, okay, you're not even aware that it's running on Kubernetes. So, okay, you need to deploy some automation. In the past, we were using like an Ansible script or Terraform script. Today, oh, by the way, you can do that. Just use this. And in the backend, it's going to be talking to Kubernetes. Just use YAML, like operator, right? The same principle as for our databases, but just use an operator and YAML to deploy anything on demand. I think it's probably, YAML is not super popular for developers, but the reality is when it comes to do like syntax check or just building templates and customization, is quite easy, right? Another option would be JSON as well. But with those two kind of declarative tools, we can do pretty much anything on demand as long as you have the right automation engine. In our case, I think Kubernetes can pretty much do it all. Right?
Very, very good. Cool. Let's keep going.
Okay, so now I'm going to be focusing on how to do, end-to-end, bring these on-demand resources and on-demand, kind of workflow within Kubernetes for pretty much everything, including when you have persistent data and stateful, applications that are involved. And this is why I put this title together, right? We want to also integrate this data aspect into this. But first, we need to do a couple of assumptions simply define what on-demand provisioning means. So again, putting myself into the shoes of a developer. So in production, like developers, they don't directly connect to the cluster. And typically, developers should not get credential of your production cluster. It's pretty bad. It's pretty bad practice. So, but still, when the moment has come to deploy into production, you still want to have on-demand capabilities, except that it's not going to be done manually by the developer. But let's say when an application owner or a special team needs to deploy an application, it should be as simple as just clicking on a button and suddenly everything is magic, right? So including the data bits, so the stateful sets, including the stateless services, the provisioning of data if you need some replication on the data by using a solution, like Ondat, or there's other solution as well, but to give you this extra enterprise ready features for your data, because you need some sort of advanced features such as replication, security, with encryption, all of that. So you want to make sure whatever tool you're using that you can tick this box, because otherwise you won't be able to provide the same thing as the public cloud. Because when you put workload into the public cloud, then that's by default you can leverage high availability there. So be sure to take care of that, right? Otherwise, in staging or dev cycle, you can say, okay, the developer can make use of kubectl. That's eventually an option, because typically the dev environment has its own dedicated cluster. If you're mixing dev and prod on the same cluster and just create namespaces, you're going to quickly run into issues. So my advice is always have a dev, even a staging, different cluster. I like personally, and that's my personal preference, also depending maybe on the size of the company, but to have, let's say the tenant should be the cluster. That's the granularity I like to have. Of course, you can do it with namespaces, but problems may arise because not all objects are namespaced, especially CRDs and things like that. So you may have conflict here and there, right? So it's more difficult to manage. And another definition or assumption is the developers, they don't want to build. Maybe they want, but they shouldn't. They shouldn't build application or infrastructure manifest on their own. So typically what you will find is the DevOps team or the platform engineers are going to provide some sort of boilerplates or templates, and we're going to see how to do it later with customize and things like that. And the dev, basically his responsibility is just to change number, like, what's the size of the storage unit? What type of storage? Is it replicated, not replicated? Or, how many replicas do you need for your databases? These kind of things. You don't want to let the developer just build the whole thing, just maybe change a couple of things, because this is what on-demand is. On-demand will be essentially the query of the developers. Right? I want X amount of Y, or I need X number of something, right? And that's basically it. You don't want to go past that level, right? Because anyway, is YAML even coding, right? I guess it's also a matter of preference. And as I was saying, there's also an important part, which is the difference between stateless and stateful application, if you want to include them into your different pipeline. Because of course, how we're going to manage to deploy on-demand resources and manage the life cycle of that is by using CI/CD pipelines that we are going to be running inside Kubernetes. So which means that we are going to be using Kubernetes objects, and in the case of application that need data, So you will have your front end that may be running as a stateless application on the left here. So you see you have a service, you have pods, and typically you don't map any storage to it. For the simple reason that if you want to map a persistent, so hopefully everyone is familiar with PVC, persistent volume. I'm assuming this because we are on DoK, right?
So more than twice, yeah.
All right. So that everyone should be familiar with that. But what I'm trying to say is when you attach a PVC to a deployment manifest, all the pods within that deployment will share the same PVC. So obviously there has to be a shared file system, a shared shared storage. So typically NFS. If you try to map something that is local to your node, so guess what? So the first pod, the pod that is local on the node has access to it. If more than one pods are running on that node, only the first one, of course, will claim it and have access to it. And of course, all other pods that are running on other nodes, they won't have access to it. So I met a lot, different people who were trying to use PVC by doing like local storage, and suddenly things don't work. Obviously, they don't work because you're using a deployment and not a stateful set. And the easiest way to use to provision storage in a declarative way, and that will facilitate the on-demand approach for data. So imagine here the persistent volume is backing a database like MongoDB, for example, right? So when you declare, you create the configuration of your stateful set, you're going to have what we call a volume claim template, right? And in your volume claim template, you're going to reference a storage class, right? So you just have to do this. And as long as the storage class is provided by is attached to a CSI that can, and the storage class can dynamically provision the PVC and the backing persistent volume, you're safe. You don't have to touch anything else. So just using a volume claim template, specifying the storage class that you want, the space, the disk space that you want, and that's it. That's the easiest way to create this into a stateful set. And in turn, is going to facilitate how you can parameter this into a CI/CD pipeline. Very simple. You want to keep it simple. And yeah, so that's basically the difference. And why would you do this? Again, I'm just trying to reinforce if we are still people who doubt that DoK makes sense. So just a quick reminder. So this is Gartner, not me, by 2023. So CloudDB will account for 50% of all the DBs. And when we say Cloud DBs, again, you have to make the relationship between, okay, we have DB as a service like RDS, all those kind of things. But you can also do DB as a service inside Kubernetes. And why you would want to do one versus another? If you ask me, DB as a service in cloud providers is super expensive, right? So if you have the money for it and if you don't have the possibility to invest into internal skills, because of course, if you want to do it in Kubernetes, you need the skills to do so, right? But if you do it in Kubernetes, if you implement your own version of database as a service in Kubernetes, the cost will, dramatically be reduced. I don't know, maybe 50%, even more than that, right? But of course, you need to invest more in people. But there are a couple of benefits: more control, reduce the cost, etc., etc. But both are part of the cloud. Let's say the cloud landscape. DB as a service, running DB into Kubernetes. The way I interpret this data there, 50% is both, like it's for, everything included. So Kubernetes, hopefully, we're going to see more and more people adopting this kind of DB as a service inside Kubernetes. I think there's so many benefits. And again, here I've put some data from Datadog. That's typically, that's the container images that are used by enterprises. So you can see that among dots 2, 4, 6, 8, 10, 16 or 14, there's half, so 16, half of those are databases or stateful application. So effectively, what I'm trying to say is that this is a thing, right? But hopefully everyone already knew that, but just in case. So now I'm going to give you a couple of tips to make, just before going into the demo, to make these on-demand resources possible into Kubernetes, and all those elements should be part of your pipeline. So of course, stay declarative as much as possible. The first tip, if you want to deploy a database, use an operator. Of course, why? Because again, you're going to configure the database as YAML, not because it's fancy, just because it's YAML, right? So YAML means that you can use templatization, you can use any tool to customize that. And also what it allows you to do is not only to manage the configuration of the underlying infrastructure, so the stateful set, but also the configuration of the database itself. As you scale your database, as you scale your stateful set, the database will scale as well in terms of the database itself, number of replica, whatever is primary and secondary. The operator helps you achieve this, right? So it's really, really key to that. Second tip is, if you want to make your application available on demand, you have to make it Kubernetes native. What I mean by that is typically when you start developing an application, a lot of people are using configuration scripts as part of the code, as part of the application. You shouldn't do that in Kubernetes if you want to maintain this on demand and have the ability to use the Kubernetes paradigm to change those values by using, again, YAML, templatization, customize, and CI/CD pipelines. So you want to decouple your code from the configuration. And there's different ways to do this in Kubernetes. So we have a lot of different first-class citizen and primitive. We have environment variable inside Kubernetes. We have volumes you can mount, and using the downward API. So the downward API, if people are not familiar with that, it's a very simple concept that allows you, as depicted there, right? So as part of your manifest, your application manifest, you're going to reference other objects that are living within the Kubernetes APIs, right? So maybe you want to inject some labels, existing labels in Kubernetes labels into your application to have more context. So essentially, it's making your application aware of some values that are set in the cluster. And of course, there is another way to do it, which is the one I've represented in blue/green there, which is from your application, query the Kubernetes API using your basic service account, right? Every pod mounts a secret that gives you access to the Kubernetes API to perform queries. But I would say if you can avoid it, avoid it. It's not really, if you want to use like simple things that are available by default using the downward API, then just use the downward API. I mean, you can look into the documentation. Downward API won't cover all objects, but if you can do it with the downward API, this is the real pattern. Just using the pod and the service account to query the Kubernetes API, it's also another pattern, but sometimes can be an anti-pattern, right? If you can do it with the downward API. So just be careful of that. I'm going to continue the rest of the tips, but this time I've been covering, what is specific to Kubernetes in terms of objects and constraint and paradigms. Now I'm going to go into how to, that was more like, why to do it in Kubernetes and a couple of, objects there. But now I'm going to focus into some paradigms that you will be using to deploy all of that, to realize all those operations, this from start to end, no manual action when you want to deploy your application, including the configuration, including the infrastructure bits, which is the storage layer, the network layer, using those paradigms. So two main paradigms, one is shift left and the other one is Git Ups. So the first, I'm going to start talking about the shift left first. So shift left, I don't know if people are super familiar with that. Originally, it is a concept that is coming from the software engineering side of the house, where the idea is to bring your testing as close as possible as the original, development cycle. So you want to test your application, and it can be things like integration test, smoke test, a lot earlier in the development process. So why you want to do this is there are studies that show that the later you start, noticing bug and fixing bug, the most expensive to fix those bugs it is, right? So you want to be able to detect bugs very early in the development cycle, and for this, you also need some infrastructure component, because if you need, I don't know, some storage, if you want to test your application in situation of production, then you need also to bring the production, the environment that is used in production. You want maybe a mirror of that, right? So for this, you need the infrastructure component where your application is running. So this is why the shift left paradigms is not only about the development practice, it's also about bringing the infrastructure component early in the cycle. So what that means in terms of Kubernetes, it means that your manifest needs to include proper configuration of the resources that you need. Can be things like network policies, can be things like, we are talking about storage. Again, if you're using solution like, OpenEBS, Portworx, Ondat, all of that, you want to get the configuration as early as possible into the cycle, which means that possibly you want to use a solution that is declarative as well. So always, as long as the configuration is declarative, you can bring it and shift it left, because again, it's YAML, it's declarative, right? And of course, it comes with a few benefits. So doing this, as I said, it saves you time, because now you can fix bugs a lot earlier in the process. It gives you agility. You can change things a lot faster. You also produce higher quality software because you have less bugs. So less bugs mean more quality for your software. It helps you build anything as a service, because now from the beginning, from the developer to the end, into the deployment into the production, everything is deployed on demand. So it helps you achieve anything as a service, like database as a service, or machine learning as a service, or pretty much anything you can think of. Again, can be think outside of the Kubernetes cluster as well. And now, because everything is represented as text, as YAML, it's a lot easier to put everything into your source control, version source control like Git, because you can run some tools to detect, any compliance issues and achieve and enforce things like policy as code, right? We're using OPA Gatekeeper or these kind of tools as well. And the last part is about Git Ups. So we've seen shift left is basically about automating things as early as possible and giving people the ability to customize those definitions. And Git Ups is how do you deploy into Kubernetes? It's basically how do you run your CI/CD pipeline? Because remember, I said no kubectl into production. So what that means is, if you look at the picture here, a typical Git Ups pipeline starts in the same way as a normal CI/CD pipeline. So on the top, you will see the developer commits the application code. Then it's going to trigger, the CI is going to trigger the image build into a particular registry like Docker Hub or whatever. And then this is where the Git Ups pipeline is going to start. The Git Ups pipeline will essentially monitor a repository where you have all the application and infrastructure manifest. And the idea of the Git Ups pipeline is every time you will have a build that is going to update the image. So from the application code, you have a new image. The image is updated within the application manifest. Then the Git Ups solution, or typically it's also an operator itself, right? So it's going to watch, the operator is going to watch for the CRD that is mapping to your Git repository. And every time you have a new version or new changes that are defined or that come into that repository, you will have your GitOps pipeline that's going to push those differences into the Kubernetes cluster, and that that is going to basically reconcile what you have in the Kubernetes cluster with what the definition of your application is in Git. But remember at the beginning, I've said, look, with Terraform, you cannot do the opposite way. With Git Ups principles, you can also do it the opposite way. So by using your what is effectively running inside Kubernetes and choose to sync in the other direction, right? So this is why it's so powerful. And of course, you have benefits because now you don't use kubectl to deploy things. No one has access to the cluster. It's just a process as part that is happening as part of the CI/CD pipeline, right? And that's awesome because from a security perspective, this is obviously ideal. Okay, so I'm gonna go just to the demo. We have what, about 20 minutes? That should be enough. So just the way I'm introducing what I'm going to show you is, I mean, the Git Ups pipeline I've shown you before is super simple, but in reality, CI/CD pipelines are more convoluted. And there's a name for this in English. This machine is called the Gold. Can't remember the name of that. Maybe Bart, you can help me. It's called the Goldberg machine. No, Gold something machine, right?
I don't know, but I'm going to look that up. I'm curious. It reminds me of the game Mousetrap, but I'll look that up.
It does have a name, a special name. These things where like you do something and then it's all this fancy stuff is happening in sequence. I can't remember that. Anyway, so this is the demo I'm going to try to show you today. Hopefully it's going to be working. And in the end, it's going to show you this amazing Marvel application you can all have from GitHub, right? So, and this is to show you how to provision everything on demand. So it starts again with a developer. So as a developer, I want to test my application as early as possible using my local Kubernetes cluster on my laptop. And this is also something very specific to Kubernetes. You can have it run locally on your laptop. I mean, I know that there are projects to make AWS run, the AWS API run on your laptop. I know that exists. I never tested it. Maybe if people have feedback on that, but at least with Kubernetes, it's not a different Kubernetes. It's the same Kubernetes, right? So you can leverage all the Kubernetes primitives and platform to test your code and just develop within your own development cluster locally on your laptop, right? And you will have a good idea of how it behaves in once it's deployed in production or in staging, provided that you have the right tool sets. Again, you want to bring as many components as possible compared to what you use in other more generic environments. So typically, what I want to show you is this pipeline. So let's say I'm the dev. I'm developing my amazing Marvel application, which is working on top of MongoDB, which is a stateful application, of course, so which is leveraging PVC, PV, etc. I'm committing my code, and as I commit my code, I'm going to be using a post hook. So before pushing my code into the remote repo, I want to test my code locally. So as I commit my code, I want to trigger the build of my new image, right? Once the new image has been built, I want to update my manifest with that new image value. And also I want to create my own custom values for the manifests I'm going to be using in my cluster. So maybe I don't need like 5 replicas. I may be needing only 1 replica in my database, or I may need only 2 pods for my front end, not 10, all those kind of things. But again, we want on demand. So we want minimum effort. So just changing things and everything should work using a very simple script, right? Of course, here, shameless plug, it's Ondat because I'm choosing, of course, to deploy, the replication, the high availability encryption with Ondat. But you can do it with whatever, as long as it's declarative, right? That's fine. And then because we're not in production, I'm going to be using kubectl to deploy into production. But again, I'm using the Git post hook, right? The post hook. I'm going to commit the code and use the post commit hook, which means that it's itself an automation action, right? And then what's going to happen when I'm pushing the code? So I've committed the code. I've done my test, and now I want to deploy my application for maybe the QA team to further test what I've done, I want to push it into the central repo so that the Git Ups pipeline can take my updates and deploy into the staging or production environment, right? And this is where the CI starts. So Git push. So this part in the demo, I'm going to do it manually because Tekton, as I said, is quite difficult. So I didn't implement the event management yet. So instead of using a webhook, I'm just going to trigger the kubectl create Tekton pipeline manually. But it's just a single command, right? But it's just that events in Tekton can be quite tricky. Anyway, so the Tekton, it's a Kubernetes CI tools for every step that are going to build is going to be using a distinct container image. And this is amazing. I love Tekton. Tekton itself use PVC, so persistent volume claim, to NPV, so essentially like stateful data to communicate between different tasks. So for example, in this pipeline, at some point, I am building manifests with Kustomize, and those manifests needs to be injected into my manifest repository. So I need 2 volumes to do that, right? So you have to be careful because typically in Tekton, you can only enable a single volume. Here I'm using Ondat, so I can do multiple volumes. I'm not sure if other solutions allow you to do that. But anyway, just bear in mind that a single volume per pipeline if you're not using this. So the process is building image with Canico, not Docker. Why? Because you don't want to mount the Docker socket in Kubernetes. Why? Because it's unsecure, as it gives you pretty much a root access to the node. So don't do that. It's a very, very bad idea. Canico from Google. I don't know if there are people here. And that's another question. How do you guys build your container, your image within Kubernetes? Are you using Canico? Are you using something else? I'm quite curious about this too. So eventually the Canico image is, which is a Docker OCI compliant image, is going to land into Docker Hub. And then the same process will start again. We're going to be using Kustomize to customize, that proper manifest with, the environment we want. So we're not going to be applying the dev overlay. We're going to be applying the production or staging overlay and deploy that manifest into the repository that is monitored by Flux. So Flux, a tool by Weave, is Git Ups solution. You have other Git Ups solutions. So 2 popular ones are Flux, and the other one is Argo. So you can use one or the other. That particular case, I've used Flux. And then this is the, continuous delivery, right? Because we're going to continuously watching for what's happening in the application manifest repo. And anytime there is a modification, the modification will be applied into the production cluster, which of course is not using my laptop. This time is going to be using my production GKE cluster. Okay, that's about it. So let's get into it. So 10 minutes to do it. That's 12. Okay. Should be enough. So let me share is there any question on that? Because I went a bit fast. Hopefully people are already somehow familiar with the component I've mentioned today. Don't hesitate to ask question. We can.
I think it was well mapped out. So yeah, go for it.
Okay, so the first thing we're going to do, I'm going to start with my development environment. So I need to use this one here. So this is my amazing Marvel application that is there. All my IP is sitting there, right? So what I want to do is I'm going to try to build, create a new modification and then build that container and deploy my new application into my local environment. But before that, I want to show you the Kustomize, the application manifest, because this is the key for the on-demand aspect. So for people who are not familiar with Kustomize, so Kustomize is now part of the kubectl. So if you do kubectl-k, it's going to be probably, using an old version of Kustomize. This is why personally I prefer to use the Kustomize command line. But yeah, it's available by default in kubectl. So the idea is you have a base configuration that is defining, your application. So in my particular case, I'm using a deployment for my Marvel app. I've got front end. So this is a front end essentially. And you can see here, I'm connecting, even though I'm deploying a 3-node MongoDB, I'm only connecting to the first one because I'm lazy, right? It's the first version of this whole demo, so it's not perfect. Don't blame me for that, right? But typically, I should connect to every node properly in the MongoDB cluster. Let's do it this way for the moment, right? So I'm passing certain variables there that I'm going to get from from the deployment. That's pretty easy, right? In terms of Mongo, same thing. I'm defining the service, headless service, because it's a stateful set. So you need to define a headless service on top of that. And the number of replica here can be any number because I'm going to modify it with the overlay anyway later on, right? So that doesn't really matter. Then a couple of images, version, command line. Yeah, I'm not using an operator for this demo because otherwise it would have been too convoluted. But I want to show you what you can modify. If that's an operator, it's the same thing. Instead of having Mongo-st stateful set, just bring your operator as the base and create your overlay and modify what you need to modify in terms of the section inside the YAML configuration of the operator. Same principle. And again, here, secret sauce, you want to have a volume claim template and just specifying the storage class. But again, here, the storage class and the size, I don't care because I'm going to modify it in my customized overlay, right? And basically in my customized overlay, I'm going to say, okay, this is what I want to merge. So this is the local file that I've got underneath customization.yaml. So I'm going to say, I want to merge the modification that I'm going to specify just underneath, right? And also I want to change the name of the image. So what I want to do is in my dev, I want only 2 replica of my front end. I want to change the storage class. I want to use, in that case, again, shameless plug, an Ondat storage class. And I want to, configure like the number of replica from the Ondat, backend storage. I want to have 1 replica of that because I'm running in dev. In production, I may want more, right? That's basically it. So what it's going to do when I'm applying the customize command is going to change all my base configuration to reflect what I've got here. So essentially, as a DevOps engineer, you give this to your developer, and the developer will probably do, okay, I need just to change this, right? So this is one part of the Ondemand. I just have to complete this little files, and then the implementation of that will be done by the CI pipeline. But this part is really key because it gives you like a bullet plate that you can modify on demand. Production deference, I will need to run 5 replicas, and I want to delete the storage class because I want to use the storage class that is already provisioned in my production environment, and that is named, in my case, on that another type of storage class, whatever, right? And as a result of that, I'm going to generate a manifest, which is empty at the moment, because if I run in production, my CI pipeline, remember, is going to generate the manifest there, and the Git Ups pipeline is going to monitor what is in this file. So currently it's empty. Once I run the pipeline, it will fill this file with all the manifests that define my application and apply this into Kubernetes. I hope that makes sense. But for the moment, I'm going to run the development pipeline, which is essentially here. Post commit. This is my pipeline. Super easy. I'm building across a platform image because I'm running on M1 on my Mac, so you have to do this. Then I'm using customize build to create my manifest, specifying I want my dev overlay. And then I'm just going to apply this manifest using kubectl, right? So let's, instead of Git Ups, so let's simulate this. So I'm going to just touch tests, right? Okay, I've got a test. I want to commit this. So git add test. Okay, git commits, add test. So, and before I press enter, I want to show you. So this is my, on the top, this is my local cluster. And I've got, I don't have anything there. So I'm going to monitor what's happening there. So I should see things popping up there. Right? committing this. Okay, so I'm building the new image with the new code, pushing the image into Docker. And once I've got the manifest, yeah, kubectl is going to populate the cluster with all those definitions. So the way, I mean, I've got all those manifests. I have a batch because the way the Marvel application work is that I'm not querying the API, the Marvel APIs directly. What I'm doing is I'm using the job to query the API once, and then with that job, I'm populating my database, my MongoDB, with the data I've gathered. Probably, I mean, there's thousands and thousands of data and entries you can get from Marvel. I think I choose like 600 or 700. And then I'm caching this into the database, and the application, the Flask application I'm using is just displaying that information with a nice, bootstrap sort of template, right, to make it, nice actually. So this is why I have a job. Okay, so you can see that MongoDB has been provisioned typically by an operator. And here I've also added the data with my job into MongoDB. So if I do a get pod now, you can see everything is running. I've got my service that should be running as well. I've got my Marvel front end. So let's check that the application is working. Like, did you sacrifice a goat before? Okay, this is running on AT-AT. Let's go to this localhost. Let's pray. Yeah, we made it. So now we can spend the next hour just looking at what is there and change all the code. So this is my, let's say this is my dev application. I'm happy with what I have and I want to push it into production now. So typically what I would do is I would do a git push, right? And automatically it should trigger my pipeline. But as I said, I'm just gonna do it manually, but don't tell anyone. So I'm gonna go into my Tekton pipeline. So Tekton, yeah, you have to spend a lot of time to, I mean, it took me like almost 2 days to make this simple, I mean, simple, not so simple pipeline, but yeah, it's super flexible. I like it, but you have to spend some time. The learning curve is quite, yeah, it's quite steep. So yeah. But what we're going to do is run the production pipeline where I'm specifying now the customization using the production environment. So now it's going to deploy into the repo, and then Flux is going to monitor in production. So if I do like a pod there, I have no pod in production. I should see also that with Flux, what is a tree? I don't have anything deployed yet. So once Git Ups and Flux will take and so grasp all the, get all the information, is going to deploy it, and you will have a new tree that is going to be appearing there. So just for the sake of it, we're going to trace the MongoDB as well. So the last is not there. I think, yeah, it's not there. There's nothing. There's no object in deploying the cluster, which is what we want. So let's trigger that pipeline. So for this, I'm going to be using, as I said, command line, but it's quite easy, right? It's just, again, declarative. I'm going to apply my pipeline run. And by doing so, I'm going to create a CRD, which itself, you have a controller, a custom controller that is going to monitor that and trigger all the action. And those action, you can do that pipeline run logs to see what's happening. So again, I'm using Kaneko this time to build the image and then inject all my on-demand, infrastructure resources configuration into the different manifest with customize. And then I push this into the repository that Flux is monitoring. And then if all goes well, the Git Ups pipeline is going to deploy this into the cluster. So we can check, yeah, not there yet. So you're going to see same thing. Not ready yet, completed. So now, yeah, the manifests. So you can see every step of the pipeline is a container. So this is the image build. This is the customize, section. And at the end is going to end up with just pushing those manifests into the Git repository. And that's basically it, right? So it's really like deploying container on demand as you go through your pipeline. It's really Kubernetes. Nothing from what I'm showing today, nothing is running outside of Kubernetes, which is why, I found it really amazing to get all this automation inside Kubernetes. It's really super powerful. Okay. So now customize as build, pushing, so all the Gits workflows. So now I should see the, okay. Manifest, please, Git Ups. Don't do that to me now. So now I'm waiting for Flux to pick up. Okay, it's there, right? So now if I trace the object, yeah, you can see the last time it's been reconciled. It's basically now. So let's check again that I have my pod running. So you can see again, now I've got my stateful workloads deployed, but this time with my production parameter. And again, it's on demand because I didn't touch anything, right? All the CI has done that for me with the right tool set. So just wait for it to be finished and just test that the application now is working in production. And then we can call it a day. I think we're a bit over time, but hopefully it's not too bad for people to stay 1 or 2 minutes more.
Nah, it's totally worth it. It's worth the wait.
So any other questions?
I liked one thing that you mentioned, and something that's come up quite frequently in different live streams, is the idea, and one of the benefits or why we are making the case for data on Kubernetes is being able to run absolutely everything in a Kubernetes native way and not do anything else outside. You've been showing a very good example of that. Is this something that you expect to be happening more and more in the near future, or do you think we still got to wait a while?
Yeah, and I will be the best advocate of that. I can, because this is what I want to see. Again, this is back to the first discussion at the beginning when I said, it's just a matter of cost optimization and running. You don't have to run everything into Kubernetes, but it's such a beautiful and well-engineered platform, an extensible platform. I call it cloud in a box or data center in a box. You have everything available through software plugin. It's amazing. Anyone can plug its own IP, its own feature, and leverage that to do anything. So yeah, of course. And as much as I like to consume things in public clouds, you get more control when you get into Kubernetes. So for like enterprise customer who wants to implement compliance and get more control, for example, like managing your keys. If you encrypt things into AWS and you're using AWS KMS to manage your keys, it basically means that AWS has the keys to decrypt what you have encrypted. Does that make sense? I'm not sure. So, there's a lot of different arguments of why you want to do it inside Kubernetes.
Yep.
And I will be definitely an advocate for that. And yeah, I'm really hoping that people continue to do that. And as a community, again, remember this conversation we had on the Twitter live stream, we have to bring the best practices as people move towards that kind of direction. Right?
Yeah. And because that also touches on another point that you mentioned about cost, is that there will maybe cost reduction in infrastructure and tooling. If you're adding cost in people, that's also, once again, get those best practices out there so it doesn't take, it's a people question, but it's a timing question. If it takes someone 6 months or a year to get up to speed on this, then that's very expensive. If there are communities of practice such as this one that make available those best practices so it's easier, then the troubleshooting saves you a lot of headaches.
Yeah, exactly. That's exactly the point. So yeah, hopefully I've managed to convince people today that just do everything in Kubernetes, everything you can. But yeah, just to check the application is working. So now it's 8080 in production. I'm just gonna refresh that. But yeah, I have no doubt this amazing app should be working. Yeah, of course it's working. Why not? So if you want to try it yourself, everything is on Git. My handle on Git is V55, all spelled out in letters, just there. If you go on /v55 here. I've got my repositories there. I've got this demo app. Yeah, I'm going to put all the stuff I do is there, so you can pick the image as well and play with the application, or you can even enhance it if you want, make fun with it. That's perfectly fine. And yeah, just as a conclusion, I want to sum up what we have seen today. It's just like the last slide. So key takeaways for today, guys. Hopefully, Cloudnative is a mean to an end. Only use public cloud services that make sense for use cases. Don't think necessarily, okay, I'm going to use everything in AWS because AWS is cloud. Well, no, the real framework to build cloud application, guess what? It's Kubernetes. It's our cloud native, community. Kubernetes operators, Git Ups principle, also with the shift left paradigms, are really key to creating a standard framework that, of course, enables self-service or on-demand resources for developers, but not only developers, for other people too, of course, that include databases and other stateful components. And this is what we want to focus on too. You don't want to have only your stateless workload there. You want to take the same advantage with your stateful application in your databases. And the last one, when decoupling data and configuration from the application code, remember download API, make your application Kubernetes by decoupling configuration from the app, then Kubernetes can act as the automation engine from pretty much any API-driven resources, including external infrastructure component. And this is where I want to bring, this is the next step, where I want to see us as a community, DoK community, but like the Kubernetes user is to start using Kubernetes instead of Ansible to automate your network provisioning, even on-prem. I worked for Cisco for 6 years, and one of my talks were all about automating into Kubernetes as well, using things directly, even if it's a Terraform operator. Actually, you have a Terraform operator that exists. It's not super famous, but you can deploy your Terraform script into Kubernetes as CRDs, and automatically you will have a controller there that is going to make the Terraform script run into Terraform Cloud. That's amazing. I love this kind of stuff. Well, of course, and you have Crossplane that can also allows you to do that. So also check out Crossplane. I think that's it for me today. So again, thank you, Bart, for having me. I had fun. Hopefully, everyone here too.
I'm certain they did. Can you stop sharing your screen though, really quickly before we finish up? Because speaking of fun, this is very important. As is tradition in our community, while you were talking, we have an amazing artist who's working in the background. Let me know when you can see my screen.
Yeah.
So
nice.
He was able to get a visual summary of the stuff that was going on there. Obviously, there was a lot that was covered. Would have to do a separate drawing to get all the wonderful Marvel characters in there, which I think is so cool. And I think this is a really good lesson to anybody out there who wants to make this more fun, enjoyable, and accessible. Try to find ways to make it fun. And also then you'll be more motivated to work on it, because you're like, no, I'm not like, running just through provisioning or things like that. I'm interacting with something that I enjoy in my free time. So why can't I mix that with my job? So I think that's a really, really nice lesson to everybody out there. Nick, thank you very much for your time today. We will definitely be having you back, and hope to see you in London in early 2022. Thanks everyone for joining. I left a link for Nick's blog. You can find the new blog. It's not yet on the Ondat website, but it is on Nick's Twitter. So if you want to check that out, you can find that. And as always, a pleasure to be with everybody. Nick, thank you very much.